Oldcastle Infrastructure presents CivilSense, our AI-driven water asset management and leak detection platform and service. In our world today, 2.5 billion people live in water-stressed areas, while 4 billion people experience water scarcity for at least a month a year. The U.S. isn't immune to water scarcity either. According to the EPA, 40 of our states don't know where they'll get their water from in the next decade. Infrastructure is aging and failing, to the point where 35% of water is lost before it even reaches consumers. In the U.S., this amounts to 6 billion gallons lost every day and 2 trillion gallons lost annually. However, there is a solution. CivilSense, developed by Oldcastle Infrastructure. CivilSense combines predictive risk analysis with real-time leak detection to provide you with actionable insight that can help reduce non-revenue water, deploy resources more strategically and effectively, and save money. In this video, we'll introduce the predictive risk analysis capability of CivilSense and show you how you can use it to identify areas of high risk and high impact in your water distribution network. We'll start by highlighting and demonstrating the improvement in accuracy and performance that artificial intelligence and machine learning can provide over traditional methods of ranking pipes, such as the age of the pipe and the pipe's break history. Utilities across the country often struggle to determine which pipes are in good condition, which pipes should be left alone, and which pipes should be replaced, inspected, or prioritized for leak detection. The reason for this is that there's very limited data for decision-making. Utilities have traditionally relied on a very small number of data points for calculating the likelihood of failure, with the two most prominent being the age of the pipe and that pipe's break history. This is where the artificial intelligence and machine learning of CivilSense really takes over. When calculating not only the likelihood but also the consequences of pipe failure, CivilSense considers a range of data points from every direction, such as in-pipe sensors, past pipe history, the type of road the pipe runs along, the pipe diameter, and the presence of nearby critical infrastructure such as hospitals, schools, and health centers. We can see that in these two graphs. We've ranked every single pipe segment at a particular utility according to its break history or prior failures. That's shown in the top left of the screen. On the top right, you can see the same utility with all pipe segments ranked according to the age of the pipe. Each of those dots represents a main break or a leak that occurred at this utility in the year following these rankings. Now we can ask, where did that particular pipe fall within those rankings? We've color-coded breaks to show you which breaks were the first time that these specific pipe segments failed. These are shown in blue. Repeat breaks, on the other hand, are colored red. These are breaks or leaks on pipes that have already failed 2 or more times in their lifetime. Pipes that are going to fail are shown at the very top. What that tells us is that most of the failures occurring are in pipes that have failed before, and that these pipes will continue to fail unless they are repaired. If we look at age, both old and new failures appear near the top of the rankings. Therefore, we can infer that pipe age is not a very good indicator of break risk at this utility. In addition, many users of CivilSense like to monetize the consequence of failure, so CivilSense enables this activity to help you map out budgets and potential expenditures. Finally, the platform combines the likelihood of failure and the consequence of failure to determine your business risk exposure, or BRE. This helps utilities to quantify and prioritize the true risk inherent in the system. In addition to the core risk analysis tools, CivilSense offers a planning module that enables you to prioritize investment and resource allocations. The Planner module looks at activities such as replacement, rehab, and condition assessment, and it uses the risk results to ensure that you get the most value out of those projects. For example, a pipeline replacement project. We want to replace at a neighborhood level, excluding any replacement that's less than 500 feet or more than 10,000 feet. You can adjust cost settings based on the cost of replacing a pipe or performing a condition assessment. You can also select which pipes are used for specific types of activities. You can also select specific user-defined business rules. In this example, let's say your utility has decided to replace pipes, where the likelihood of failure is in the top 20% of the system and where the remaining useful life is less than 20 years. You can input a budget. For example, your utility has $10 million to spend over the next 12 months. How does it turn that into actionable projects for pipeline replacement? The platform will allocate the available budget across the highest number of high-priority projects that can be completed within the defined time frame. You can also edit all of these data points. For example, if a repair crew is scheduled to work in this area, a pipe from this analysis can be added to that schedule. These are all highly customizable. Start dates can be moved. Rules can be added to prioritize pipes of a certain material or size, and these can all be saved for future review. With these saved projects, you can also run reports to show the impact on a pipe's remaining useful life, as well as show that pipes cost over time. Alongside the Planner module, there is also an Analytics module. You can take the likelihood of failure results from CivilSense AI and combine it with extensive industry data to calculate the remaining useful life of the entire system. This helps you understand which pipe segments are hitting the end of their useful life and what kind of capital investment is needed. Clicking on any of these graph elements will take you to the pipes in question. The Analytics module also shows pipes by material type, failure rate, condition, and so on. All this data is easily exportable in spreadsheets or in PDF format. Utilities, quite rightly, focus on areas of the network where they need to invest the most. The highest priority sections of the network are the ones that need to be inspected, rehabilitated, or replaced. However, what is often overlooked is the opportunity cost of investing in areas of the network that do not require investment. This represents resources that are being wasted. Without reliable predictive analysis, the true risk profile of the assets within a system is unknown, and you are then forced to make decisions based on partial or unreliable information. The true value of CivilSense predictive analysis is not only in directing resources to the areas of the network that are the highest risk, but also in preventing resources from being wasted on areas of the network that are the lowest risk. By using AI to analyze the true risk across the network, CivilSense drives efficiency in investment and resource allocation, maximizing value for money and preventing costly, disruptive main breaks.